So next will be the last sessions of today's program. So let's move on to the next sessions. So may I introduce our chairperson, Dr. Franz A. De Leon, Department of Science and Technology, Advanced Science and Technology Institute. And our keynote speaker is Ms. Riza Carmela Marron Pineda, Advanced Science and Technology Institute, Philippines, with the title, LokaLTE, a case study of using LTE community cellular network to enhance digital learning in the Philippines. Please welcome.
Good afternoon to each and every one of us. I know that we are a bit tired already. It's late in the afternoon, but I'll try to make my presentation as interesting as possible. So yeah, I am Riza Carmela Pineda from the Philippines, and I will be presenting LokaLTE, Project LokaLTE, which is a case study of using LTE community cellular network to enhance digital learning in the Philippines. On March 15, 2020, our president back then announced that the entire country would be in a total lockdown because of the COVID-19 pandemic. And some of the communities weren't able to watch the televised press conference of the Philippines, of the president of the Philippines. Some communities weren't able to receive the information about the lockdown. And clearly, we can say that in our country, there is a digital divide or digital gap. By definition, digital gap is the gap that exists between individuals who have access to modern information and communication technology and those who lack access. We can see there two photos on the screen. One at our left are students who are studying using a laptop. And then the other photo are students who are using or who are just having a pen and paper or their module. And in here also we can say that there is a digital gap or digital divide. And in the Philippines, during the lockdown, the schools were forced to implement remote learning. But there is a challenge in implementing the remote learning in the Philippines because of the lack of quality, reliable, sustainable, and resilient ICT infrastructure. Furthermore, the big players or the telecommunications companies in the Philippines that use conventional profit-oriented solutions can fill for all available needs, which means that there are communities that were unserved by these telecommunications companies. So there must be an alternative solution. So we must bridge the gap. Our agency, the Department of Science and Technology, Advanced Science and Technology Institute, through Project RAIN, or Resilient Education Information Infrastructure for the New Normal, focuses on developing application frameworks and infrastructures to support the shift to remote learning and to minimize, if not bridge, the digital gap in the Philippines. And one of the components of Project RAIN is the LokaLTE. It is an LTE community cellular network operating in band 71, or that is in 600 megahertz. It provides digital connectivity and internet access to underserved and unserved areas in our country. To give you a quick overview of the LokaLTE system, we have three subcomponents. The first one with a LokaLTE SIM. So there must be a user equipment that is capable for band 71, and it must be installed with a LokaLTE SIM. Then the other subcomponent is the LTE base station. It consists mainly of the radio access network, or RAN, and the core network, and they are co-located. And then the other one is the backhaul, or our internet, which is the connection to the outside world. To implement our system, as mentioned a while ago, a Band 71 enabled user equipment must be purchased, and we purchased also blank SIM cards. We have written information to these blank SIM cards such as IMSI and MSISDN, or the identity number, to connect to the LokaLTE network. For the LTE base station, we had designed an RF front end that is operating in band 71. We have implemented a software-defined radio RF front end combination, and we have implemented the APC through an Open 5GS and the eNode B through an SRS eNode B. And then we also have a pilot site already. This one, the one at on our screen, is in Tanay Rizal, one of the provinces. San Andres Tanay Rizal is one of the provinces in the Philippines, and we have put up a base station there, or a tower, with a VSAT. So we conducted some preliminary tests, field tests in this pilot site, with a transmit frequency of 634.5 megahertz. The bandwidth is 50 megahertz. Our transmit power is roughly 29 dBm, and the antenna height is 11.7. And we found out that this is just a preliminary investigation or test, and we found out that we can receive the signal at a distance of 125 meters. So we need to enhance that yet. For the impact of our project, we believe that our technology, the LokaLTE, could be a technology demonstrator to motivate the relevant spectrum policy reform to empower community cellular networks in the Philippines. Because in the Philippines, we haven't applied, or the community cellular network is not implemented yet, or not in full implementation, I should say. We could repurpose the freed up spectrum because of the shift from analog to digital TV. So there will be a freed up space and that could be repurposed for mobile communications. And of course, using SDR-based radio, it would be a low-cost network equipment. There are also scientific, societal impact. It would support the education sector and even healthcare if we would expand the applications of the LokaLTE network. It would reduce social isolation because the community could connect to the outside world or connect to their loved ones who are not living in their community. And it could also develop jobs or access to markets. For the collaboration, we have partnered already with different agencies for their digital content. We have partnered with Department of Education for their educational videos. We have partnered with Bangko Sentral ng Pilipinas, or that roughly translates to Central Bank of the Philippines, for their videos regarding financial inclusivity. We have partnered with Ateneo de Manila University, a university in the Philippines, with their Math Plus project, which is a collection of interactive applications regarding math. And we have partnered with Science and Technology Information Institute through their Starbucks project and the National Museum. We have partnered with various LGUs for our pilot sites. We have now 4 pilot sites, and we have partnered with the different regional offices of the Department of Science and Technology. But we are looking for more collaborations. We are looking for more partnerships. So this is just a quick overview or a display of some of our partnerships. Let me pick maybe 2 photos from the pool of photos. The one at the top left corner of our screen is a photo or a screenshot of our meeting with the Secretary of the Department of Education, who is also the Vice President of the Philippines, Ms. VP Sara Duterte. And the one at the lower center of the screen is a kid or a student who is watching an educational video through the LocalFlix platform of LokaLTE. So now we have developed a 4G LTE community cellular network that is working in band 71. We have developed a LokaLTE portal responsible for the billing management system, and we have developed our LokalFlix, which is our version of Netflix, where we have locally cached educational videos for the students. For the long-term output, of course, the promotion and implementation of policies. It could uplift the socioeconomic conditions of rural areas in the Philippines. It could empower communities. And it could, through this project, we hope that the Filipinos and other Asian countries would better appreciate the technology and science-based interventions in nation building. Where we are now is that we cannot deploy the Band 71 yet because we haven't secured a permit to operate in Band 71 in our country. That's why we are here. Maybe some countries would adapt our technology. We could have collaborations or partnership. But this does not stop us in conducting research or implementing other technologies. So instead of deploying the LokaLTE, which is an LTE community cellular network, we opted to deploy the LokaLFi, which is a long-range Wi-Fi. But the locally cached content and other services are still there or are still provided to the community. So shown on your screen is a screenshot of the captive portal of LokaLFi. It could be used through a voucher or a login credential, and we have provided some free web apps, the LocalFlix, the Cubics, which is an offline and verified version of Wikipedia, Starbucks, and MathPlus. And hopefully, I could also present LokaLFi next year for ASEAN IVO 2024. In conclusion, let me just be brief. Let us bridge the digital gap for a more literate world. And for future plans, we need to explore the bandwidth optimization solutions. We need to design a single board PCB for our RF front end. And we can reconfigure the locally cached content depending on the specific needs of the community. And of course, we need to process this permit for the operation of the 600 megahertz so that we can deploy the LokaLTE community network. Before saying thank you and answering your questions, I would like to appreciate the efforts of my teammates who are not here, but I am pretty sure that they are watching through YouTube. Engineer Philip Martinez, Engineer Ramon Raro, Engineer Jerome, Villamater, Mr. Kenneth Sumalinog, and Engineer Jethro, Betsayda. So if you are planning for collaborations or some partnerships, you may contact us through our email and other social media accounts. Thank you.
All right, thank you, Ms. Pineda. So the floor is now open for your questions or comments.
Yes, it's a very good project. I think that you implement the local 4G LTE, isn't it? Yeah. And then since they're using the band 71, I'm not quite sure is the legal for use for the public use in your country.
Yeah, that's the problem. They have, when we had a meeting with the regulatory board in our country, they said that they have given all the bandwidth to some of our telcos. So their suggestion is to partner with our telecommunications companies. So that would be what we would polish in the future.
Okay, so it's not the unlicensed spectrum at this time, right?
Yeah.
It's a licensed spectrum owned by the operators.
Yes, it was
Something.
privately owned.
And then my last question is like, I would like to learn about the coverage, how big the transmitted power or something like that for your system. And I think that the cost for your system, the most expensive one will be the radio unit, isn't it? The core network is not
Actually, the cost of the radio unit, this one, the RF front end, is a bit cheap because we locally designed it. But if we would compare it to the commercially available, this is this is cheaper.
cheaper.
Yeah.
And then the transmitted power and the coverage.
Yeah, for the transmitted power, since we don't have a permit to test a far area
Yeah.
because of some legal issues. We have tested up to 200 meters only. But actually, we have no. This was
So the
presented.
coverage is
Yeah, this was
200
presented
meters.
200. But yeah, I think last week or 2 weeks ago we had up to 300 meters. But we cannot go
So the
beyond that.
transmitted power may be like 100 milliwatt or 200 milliwatt only, something like that.
I forgot to
Something.
convert.
Yeah, yeah,
Let me
oh, okay.
let me
Yeah,
convert
I'm-
to 29
I'm sorry,
dBm.
I didn't see
Yeah.
the table.
29 dBm.
Thank you very much.
Yes.
All right, next. Sir, and then sir.
Okay, thank you. Well, only want to ask. Well, one comment is, you still, you mean new normal is like the COVID time when you are for the new normal. Is it new normal? What you mean by new normal? Is it where you have many education online, or?
Yes.
Because many education now are
Exactly.
moving from online to offline, and the need for online education is reducing. That's number one. And the second one is how do you compare your LTE system, at least the cost with satellite-based, low Earth orbit satellite-based like Kuiper, Starlink, whatever. You know, there are several of them.
All right.
And
Okay.
they always say that we are competitive even with cellular companies. So I just want to get your
Okay.
opinion. Comment on that.
Okay. So the first one is about the new normal. You are telling that we might be going back to the old normal, but actually we cannot run away from the digital or the online learning anymore. If you would observe the education sector, I'm not sure if with other countries, but in our country, most of schools deliver online classes or online delivery of content even now. So the new normal is really, we should accept that this is the new normal already. And even now, for conferences and forums, we have virtual conferences which we cannot run away from. And then for the second comment, which is, you mentioned one of the internet providers, Starlink. The Starlink provides internet only, whereas for the LokaLTE, it has other components or areas or services that we could offer. Let me just show you. So here, yeah, this one. So we have some educational videos or locally cached content. So with or without the backhaul. So let me explain this further. So with or without the backhaul, the LokaLTE system would still be operational and would still be used by the community because we have locally cached content. Though they cannot connect to the internet or they cannot use the messenger or any messaging app, but we have provided other services.
Mr. Anor.
Thank you very much. Actually, I have 4 questions.
Or, yeah.
2 minutes, 2 minutes.
Yeah. Okay. So the first question actually related to the frequency, but you answered that this is belong to the operator, not unlicensed.
Yeah.
Yeah. So actually, this is similar to what happened when we developed our Patriot.net. We are not using also the specific or our own frequency. We are using the frequency belong to the operator. So what we did is we are doing MOU with the operator and also with the government. So the government know that we develop this technology, and then the operator also understand, and we meet MOU. So that's according to our experience in the previous ASEAN IVO project.
Okay, I will take note on that, sir.
Okay, yeah. Okay, and then the second is that when we talk about the radius, the coverage, so this is 200 meters is, I think, very small.
Yeah, I must admit that it is very small, and
Yeah.
our target, theoretically, when we had computer simulation, it should reach up to 1 kilometer or more.
Yes.
But again, we can't go beyond that. Like we limit the transmit power because of some issues with trial deployment because we don't have the license to do trial deployment.
Okay.
Because in our country, even if it's not for commercial use it's not for deployment, final deployment, the use of the frequency must have a permit, and we don't have that
Yes,
yet.
yes.
So just
So
limit it.
yeah, just this is just my short observation. I
Yes,
think
sir.
you should need to optimize the power amplifier for that.
Yeah,
because
power
your-
amplifier.
Yeah, the height of your base station is high enough. I think you need to check that power amplifier. Yeah.
Sure, sir, will do.
Yeah. Okay. And then the third is yeah. Okay. Exactly in this slide, it's mean that this is still working for the private network, no communication to outside, right?
Yes, sir.
Okay. And then the last is please go to the page number 9. Page number 9, I think on the rooftop also. Okay, just 30 seconds.
All right.
I'm not sure which.
Yeah, that one. So I think if the location of base station is here, I think the student cannot get the good signal because the location of the base station should be a little bit far away.
This one, sir,
Yeah.
the tower.
Yeah.
We have tested this location already, and we can detect signal.
I mean the student under this base station.
Oh, yeah, there's still a signal, sir. Yeah, surprisingly, there is still
Okay.
signal. Theoretically, there shouldn't be a signal,
Yeah,
but surprisingly, there is.
Okay. Thank you very much.
All right. Thank you so much.
Thank you.
So for our last presentation for the day, we have from Myanmar on multilingual speech dataset for ASEAN languages.
Good afternoon, everyone. Today I would like to present about my proposed title, Multilingual Speech Dataset for ASEAN Languages. And I'm Mar Soe Naing, and I'm a research member of Natural Language Processing Lab at the University of Community Study Yangon, Myanmar. Now, let me introduce some background of my proposed title. Multilingual needs not only text but also spoken form when we share information between across language groups and the national boundary. Nowadays, multilingual speech services are growing popular and used in many application areas like medical services, tourism, and also transportation application. But it's still heavily reliant on the human operator in some cases. In market, there are few commercial multilingual speech services because the reason is the large amount of parallel speech-to-text data are not available for most languages, especially for Myanmar language. In my presentation, I will mention two popular open-source multilingual speech processing models. The first one that includes Myanmar language. The first one is the massively multilingual speech MMS project launched by the Meta AI. In this model, their datasets cover over 1,000 languages that also include Myanmar languages. In this model, their dataset based on the Bible reading to be a largest speech dataset. So it cannot cover the daily usage and common spoken style of Myanmar language, especially when we use in the speech recognition and speech translation area. Now, here is the World Language Diversity or Meta AI MMS project. In this project, the experiment and the use in three speech processing areas. One is language identification, speech recognition, and text-to-speech translation. And in this figure, I will highlight the ASEAN region. The green color the green color means the language identification text, and the blue triangle represents the speech recognition, text-to-speech, and language identification. And this here is the Myanmar. In in our language, in this morning, the western region of Myanmar, it has the green color. It means the Morin can work well in speech identification text. And the western region and the eastern region of Myanmar, the people living in this area are ethnic minority. They rarely use their official Myanmar language. They have their own languages, and they mostly use their ethnic languages. And the northern part of the Myanmar, it has the blue color. It means in this region, this Morin can work well in all text, speech recognition, text-to-speech translation, and also language identification. Because in this region, this northern part of Myanmar is also our ethnic group. The people living in this area are mostly Roman Catholic. And then in here, the central region of Myanmar, and here is Yangon, state creed color. It means in this area, their project might not be worldwide or haven't yet analyzed on this area. The major portion of this data set are in MMS, MMS Morin. The major portion of this data set is prepared for religious texts. So we need the data for daily conversation speech. There is no benchmark data set for daily conversation and common spoken style of people living in this central region of Myanmar and also Yangon. Then there are very few large-scale multilingual speech processing models for Myanmar language, and a small portion of ASEAN language are included in most multilingual speech corpus, like the Myanmar, Lao, and Khmer language also. Another popular speech, multilingual speech processing model is Whisper, launched by OpenAI. In this model, work in two text. The first one is the multilingual speech recognition, and the second one is the speech translation area. The training portion of Myanmar language in this model for the multilingual speech recognition, it has 0.1 hours in total, or 117,000 hours of speech data. According to their experiment, they did the experiment on multilingual transcription test. In this multilingual speech recognition text, the error rate of Myanmar language is too high, around 120% of what error rate on flag data sets. And then the experiment on speech translation text, the blue score is also too small for Myanmar language. It has less than 0.5 blue score for Myanmar language. In here, there is the detailed experimental result of Whisper model. There is the experimental result of speech translation area. They evaluated with blue score and experiment of flat data sets. For Myanmar language, the blue score is less than 0.5, and for Khmer language, the blue score is also less than 6.1, and for Lao language, the blue score is also less than 11. And then they also analyze on the multilingual speech recognition text. They also test on the flat data sets, and they measure with word error rate. In this text, for Myanmar language, the word error rate is over 120%, and also for Khmer language, it has over 95% word error rate. Here is the detailed statistic of training data set that are used in this Whisper model. For the multilingual speech recognition text, the training data set of Myanmar language is 0.1 hours. And then they take the translation, speech translation text. In this test, the training portion of Myanmar language is around 59 hours of speech data. From this reason, currently public available multilingual speech processing models are not enough for fine-tuning text and daily usage conversation or common spoken file of Myanmar language. I think also the same for other low-resolve ASEAN languages, especially in speech recognition and speech translation area. That it's very difficult to have the one speech recognizer or one speech synthesizer for each languages. So our focus is to develop a common multilingual speech corpus that support for multiple languages, and we build the appropriate linguistic analysis module. Our proposed solution is to create a multilingual speech corpus that are used for commonly spoken style of each languages. Then we build the pre-trained Widubert model that support for low-resolve ASEAN languages. Widubert model is one of the current state-of-the-art model for automatic speech recognition area. It is popular for self-supervision training mode. The training allows us to pre-train a model on unlabeled data. Then the model can be fine-tuned with labeled data for the particular data sets or the specific purpose. The advantages of pre-training model is we can learn the best speech representation from the input speech data. By learning this speech representation from the pre-training model, we train the pre-trained model on raw and labeled data, and then we fine-tune this pre-trained model. So we need a small amount of labeled data for pre-training text. After building the pre-trained model, and then we build the fine-tuning on this model and to do the multilingual speech processing text. The main objective of our proposed solution is to be a high-quality cross-lingual generation or cross-modality at low cost. And by using this knowledge transferring between these languages, we can relieve the data requirement. In this proposed solution, from this proposed solution, we need only one model to translate from multiple language direction. As an output, we will get an open and large-scale multilingual speech corpus for various speech processing tests, and we evaluated the usefulness of this data set by applying in language identification, speech recognition, speech-to-text translation, and other natural language processing tests. And then we will, from this world, we will get the pre-trained model, pre-trained subpoint for Widubert and that was used for speech recognition and speech-to-text translation process. Let me summarize my presentation. To the best of our knowledge, Asian language treatment, ALT Prelate Corpus is Prelate Corpus launched by ASEAN IVO from 2016 to 2019 is currently state-of-the-art Prelate corpus in natural language processing tests. So we would like to propose to build the multilingual speech corpus and multilingual speech processing model that contribute for low-resolve ASEAN languages. By combining the data from all languages during the pre-training stage, it can improve our performance when we comparing with using multiple languages at the fine-tuning stage. We want to build the first one is we want to build the multilingual speech corpus, and then we want to build the multilingual pre-training model. We analyze from this model, we analyze how Widubert model work with these different languages, and we evaluate our pre-trained model on different languages, and we analyze the impact of their performance. That's all for me. We welcome to collaboration for us, and thank you very much for your kind attention.
All right, thank you. So the floor is now open for your questions, comments, even suggestions. Yes, please, at the back.
Hi. Can I ask about the multilingual speech that you collect Is it the formal language only, or the formal with the mixed language? Like in everyday conversation, we often mix up the formal language and the informal. So whether your data sets is mixed or only formal language. And the second one, the last one, you didn't mention the improvement of the blue score. In the previous one, you said that the blue score is 0.1, but with your models or your experiments, how is the blue score now? Is it improved, or and how is it? Thank you.
Yes, the first question is for the data set, we have only in our university, we have the corpus. This corpus has 82 hours speech data corpus for Myanmar language. In this data set has news domain and news data and the daily conversation speech. Daily conversation speech around 40 hours, not only the daily conversation that use, and we use like for example, the English is where is the stadium, and I want to order some food, like that. There is the formal spoken style. Yeah. The second question is I highlight the experimental results or previous work that are used for multilingual speech processing model. The blue score is too low for Myanmar language because of the training portion of the Myanmar language is too small, and also for other languages like Laos, Khmer language also. So I think the reason is the training size of our language is too small. If we use this model, this Whisper or MMS model, we use the in our project as a pre-trained model, we will get the training size is too large, and the output result is not satisfying for their results. So we need the large data set for our language. Yes.
Any other question? Yes, please.
How big of is language for your corpus that you intend to make?
Language?
The corpus, the size of the corpus.
How many hours?
82 hours. 40 hours is for news domain, and another 40 hours, over 40 hours is for daily conversation domain. Totally 82 hours.
All right, so just to clarify, which specific languages would you like to conglomerate or put together? So, Myanmar language,
Yes.
Khmer?
Yes, in my point of view, the Lao, also Khmer and Thai, this Myanmar, also the language origin is the same. The character and the character is too closely in these four languages. So I want to put these Lao, Khmer language and also Thai and Myanmar like that.
And in the speech corpus, does it come from, let's say, different gender, different age groups for the corpus itself, for the speech corpus?
Sorry?
Does your speech corpus contain information from different genders, male, female, and different age groups, young and not so young?
Yes, in our data set for Myanmar language, also include the female or male, but male speaker, mostly a male speaker. And the age range is, this data set is created by our internship student. So the age range is over 80 to around 22, 23, like that.
Thanks. All right. Any other question? Still have 3 minutes. All right, so I guess in ASEAN, there are several countries already who have started this research many years ago, so probably you could also check their work, and of course, if there are potential collaborators, just approach them. Oh, yeah. Okay, so that concludes the presentation for the day. Thank you so much.
Thank you.